Okay, perfect, perfect. Okay, have a nice meeting.
Okay, be safe. Okay. Wow.
Ciao, ciao.
Thank you. Tammy.
Hello, hi, Ray. Ray, do you like Ray or Raymond?
You know what? Tim's my last name. I answer to anything.
Okay, well, that's good. Well, Olderico is in a train in the middle of a storm in Italy, so he had to
Wow.
bump off. So he was going to miss his train or something. So anywho, hi, I'm Tammy. Nice
Hi,
to
Tammy.
meet you finally.
Nice to meet you too. Yeah.
You are very grayed out and looking at the ceiling. Oh, there you are.
Oh, what? Sorry, I have another monitor. And so I don't know what you're seeing now.
No, now I'm seeing you, and you're looking more down.
Okay. Oh, I got a my presentation is in front of me. So let me
And then
see.
you are a co-host, so you can share and do other stuff.
Okay.
Good morning, Connie.
Okay. I don't know what you see now. Is it my
I see your
presentation?
very first slide.
Okay. Okay. You want me to take that down until you're ready?
Yeah, that'd be great, actually. I don't mind either way, but once, yeah, we'll pull it up and then we'll pull it down once we start having discussions. Oh, I don't want to see the dead birdie either.
Yeah, sorry.
Way to start the morning.
Right. Where's my Zoom? Stop sharing.
Hi, Asha.
Hi, everybody. Good evening.
Hey,
Oh, good.
Asha, did you get
Very
my
good
message?
morning
This is
here.
Connie. Asha,
Yeah,
did
hi.
you get my message? This is Connie.
No, I didn't.
I had asked if you could stay on about 10 minutes afterwards and just catch up with me what you are doing in India with the educational program. Do you have a few
Sure.
minutes after, or do you need to run right away?
No, surely I can wait.
That would be great. Thank you so much. I'm trying to do some of that here, and I thought I wanted to just touch base with you. Thank you.
Sorry, thank you. It would be a pleasure.
Is that okay, Tammy, if we just stay on this Zoom line, if you don't turn it off immediately and give us 10 more minutes after?
That's fine. I might stay on and listen as well. So we'll,
Okay, that'd be great. Thank
poor
you.
Asha was crammed into a very packed meeting last time and didn't get a whole lot of chance to speak. So, yes. I want to hear more about that as well. There's so much I want to hear more about, but my
Surely
head's starts
Yes.
to explode. So people are slowly coming in.
Tammy, where are the people in your group from? Asha's from India. And you had the gentleman from Italy.
Yeah, there'll probably be a little smattering of everything. I mean, here from Northern California, Washington, state of Washington, currently, but I'm hoping very much that Dr. Aruna Varsani from Nairobi will be joining us again, and then Neeraj, who is, oh my gosh, he writes so much stuff about environmental things. He is in India.
Mhm.
But every time is a little bit different.
Yeah.
And sometimes there's, 10 people, sometimes there's 40 people. I don't, hard to know exactly what it is. I just have to pay attention and not be talking and listen. I gotta watch the little admit button. Good morning, Howard.
Good morning. Got my coffee right here.
I know, yeah, I know. It's very early here. Ray was just asking where everyone was from. This is Dr. Homler, who is also in California, who is a retired internist.
Yeah.
And we have Miss Andrea LaCroix, who's just joined us, and she's in the Boston area. I feel like I could just sit here and push that admit button. Hi, Andrea.
Hello, how
Haven't
are you?
seen you for quite some time.
I haven't been getting emails about the meetings and I just keep forgetting. So I don't know if there's a newsletter or emails or reminders.
Now there is a newsletter. Now
Okay.
I just started one this last week. So, and I'm going to
Awesome.
get those out. Dr. Homler has very nicely written several articles that we want to get out. I'm not quite sure if they got out before, but yeah, so we want to start getting those out. And yeah, I'm going to talk more about all that.
Awesome. Quickly while I'm talking, yesterday I was in an SRAG meeting. We had a guest speaker on. I'll have to get his name. He's the plastic fisherman. Oh my God, that was so awesome. Were you on that call?
No, I'm.
Ladies, good afternoon.
Hello. Good to see you.
Yeah, I'm in the car, but in 10 minutes I'm behind my computer. So sorry for the maybe noise, but anyway, I think I'm gonna try to join. I joined before a lot of times the solar SRAC, how do I say, commission. In the meantime, they made me chairman recycling and reuse of solar panels. And I saw the agenda of this meeting, so I think I shortly join as well. So that's fine.
And Gurchan,
Maybe
where are you?
I'm in the Netherlands. I'm to be, maybe it sounds a little bit like a big mouth, but I'm an expert in waste. I'm 35 years in waste industry. So, and I'm a Rotarian in Lelystad. It's situated in the middle of the Netherlands on the lakeside. I live on the lakeside as well. I can show you. I drive across the lake now.
Oh, nice.
There's my
Oh,
house.
lovely.
My house is here. My house is here on the lake as well. So, yeah. And I'm doing a lot of things in case of recycling, but also in case of waste. And this moment I have an interim job. I'm commercial responsible for a plant of the city of Amsterdam, and we burn about 1.3 million tons of waste. but we have a lot of other recycle activities as well. So that's my knowledge and what I'm doing on daily basis. I have my own company, so.
Well, drive safely as you listen and
Yeah, I'm almost home, so I will join you via the computer in some minutes, so.
okay. Well,
Yeah,
if,
okay.
as the meeting goes on, if, right now we're all just chatting and getting to know who's, joining us and,
Yes, yes.
well, then we'll ask folks to mute, and so you won't need to worry about disturbing, with horns and driving, so,
No, that's fine.
welcome.
I'm home, so I will stop now and I will join in a minute again. Okay, bye-bye.
Okay.
Bye.
Okay.
Bye-bye.
There's lots of new people on the phone. I won't try to go through and introduce everybody at this time. I'm just waiting for people to join in, and Dr. Tim is already on the line with us. Thank you all so far for joining in. He was asking where everyone is from, and so now we've got more of a global impact here. We've got lots of people from our local Rotary and our local town. I must be talking a whole lot to them. Good morning, Miss Sherry. I will be seeing you a lot today. Sherry is my mentor in Rotary, so. Let's see who we've got here. We've got Stan and Asha, new people. Sherry, are you raising your hand? Oh, okay. Good morning, Doug. Doug is a board person from SRAG, and he is, Doug, where are you? You're in the middle of the islands.
Yeah, I'm in the US Virgin Islands in the Eastern Caribbean.
Sweet.
Yeah, it's a tough place to live this time of year anyway.
How's the weather there? Are you getting hammered?
No, actually, we're having a very mild hurricane season. It's really, this is the, traditionally the height of the season is the middle of September, and it's been really just a piece of cake. We haven't really had too many storms. So
That's great.
maybe global warming is going to have a positive impact in some places. I don't know.
Well, Alderico had to get off the phone. He is in Italy in the middle of it getting on a train where there's a horrible storm. So he prepared me for the fact that he will need to bounce out. It looks like he did bounce out, but luckily I'm host and Dr. Tim is also host. Dr. Tim likes to be called Ray, but I told him that after this meeting, I'll start calling him Ray, but today he's still Dr. Tim. Hello, Joe and Iyer and Eve Lehman, because I think this is your first time here. And Dr. Higgins. And I'm just going to give this just a few more minutes before we get started. And
I
Jeff.
put my email in the chat if anyone wants it.
Yes, that's before we even start. Because I forget to do these details, but especially if you're new to this group, would you by all means put your information in the chat? And also where you are located, and it is on my list of things to do to start a WhatsApp group for plastic solutions. So if you would like to join that, put your number in there that I would use for your WhatsApp as well. I'm just admitting everyone. So we have Dr. Jack Higgins on the phone or on the call. And in the newsletter, there will be some articles. I was just saying a minute ago, I'm going to start the newsletter coming out more regularly again, and hopefully maybe we'll see. We've got a lot of backlog of articles that Dr. Homler has written, so I want to get those out to people. And I think I will just, since it's a little after 6, I'll try to remember to admit people, and then we'll go ahead and get started. First of all, for people who are new here, my name is Tammy Mulcahy, and I live in Northern California, and I'm the chair of the Plastic Solutions Task Force of SRAG, which is the Environmental Sustainability Rotary Action Group. And we've been hosting these monthly cafes, which truly are just meant to be a way to have conversations with people. And I have found that they lend to people meeting each other who are in similar fields, and that allows us to have get some questions answered. And last month we talked a lot with Neeraj and Dr. Varsani about their recycling programs and projects that they've already been doing. And I still had some more questions about the issue of off-gassing of these products as we work towards a more circular economy, and also what is the stability of these things that people are making. And as Dr. Tim has pointed out to me, we can only do the best that we can with the knowledge that we have at the time and make the most informed decisions and then reevaluate as we go along. So with that, I want to say that it is my hope that after today, most of these talks have been very education oriented and connected oriented, but I want them to move to project oriented so that we can take this information now and build a roadmap going forward as to be able to share with other people what we've learned, and actually some almost like a recipe book. Here are projects that you can do in your Rotary clubs. Here are some simple ones. Here are some bigger ones. But start, as Doug says, project ready, shovel ready projects that can be replicated in other places. So I also just want to share too that my friend Sheridan Foster is on the line. She runs a magazine, or online magazine newsletter about green building. So she'll be very interested and can chime in here as well. So let's get started with Dr. Tim. Dr. Tim, I first met through Niru, who's not on the call yet, but I kept asking her. She is a Rotary person who is going to be helping in Plastic Solutions, and she I was asking her if she knew of anybody who dealt with this issue of off-gassing of plastics, and she recommended Dr. Tim. So he's got all sorts of certifications that you all have probably read. And with that, then I'm just going to let him go ahead and get started with his presentation. And again, these plastic cafes are meant to open up discussions so you can ask lots of questions as if you were writing that recipe book with me, as I hope some of you will be. So, Dr. Tim, I'm going to let you take it away.
Okay, well, thank you very much for the invite. I'm super encouraged that there is so much interest in this challenge that we've got. And you know, we need to really apply diverse perspectives on this problem in order to come up with the suite of solutions that we need. The problem is gigantic, and also intense, and because of that, we need multiple different kinds of solutions. We need multiple different scales of attack, and so I'm going to talk a little bit about plastics and, you know, the ubiquity of them and what do we do now. But I want to just a little bit of housekeeping first. Tammy, when I start my presentation, I only have 2 screens, and so the Zoom screen becomes obscured by part of the presentation. So if people are having questions, will you just chime in and let me know?
Sure.
And also I am going to present a bunch of information, and if there are questions and anybody has a question, please just stop me in the middle. I'd rather have a conversation than talk at you. And so I guess I'll get going. The other thing that I want to say at the outset is that in the introductory email, it said that I was affiliated with the University of Washington. I studied at the University of Washington, but I'm not currently formally affiliated there. And so the information I'm presenting is a compilation of stuff that I have worked on with some students, and over the last almost decade, trying to figure out this problem, and what to do about it. So you can see from the title of my talk that, and you all know this, but plastics are a novel material, and they've only been around for about a century. And one of the kind of issues is that we don't have an evolutionary relationship with plastics yet. And so we haven't come up with cellular machinery to deal with them. And that's a problem, because all of these chemicals that are in plastics are new. And, you know, we know that there are about 30,000 chemical formulations for plastics. We also know that very few of them, a small proportion of them, have been evaluated for any kind of safety in terms of exposure. And now,
Dr. Tim, did you want to share your screen?
oh,
We're seeing you as a presenter, but if you're looking at something that you want to show us.
I do. I apologize for that. Thank you for pointing that out. Yes. Share.
There we go.
Let me see if I can get this thing kicked back on. There we go. I put my email on here. I also put my email in the chat. So there's an open invitation for discussion. If you think about something later today, tomorrow, next week, I would love to engage. The plastic problem is it's everywhere, and my interest in it first derived from the conservation emergency associated with floating plastics in the ocean. I won't go into this particular slide, but it is really kind of indicative of what's going on. But the question is, why is there so much of it? Well, it's because it's useful. Young's modulus is a measure of kind of hardness and flexibility. And you can see that plastics are flexible and durable, and they also have the characteristic of being inexpensive, easy to make. And so we have devised all kinds of uses for them. As I mentioned a second ago, my focus started as thinking about this problem in terms of the plastic in the oceans. One of the questions was, where does it all come from? Well, about half of it in the ocean comes from ocean industry, and about the other half comes from land-based sources that are mismanaged, or rivers that are pumping plastic out into the ocean. But what you'll see here that's actually kind of interesting is that a lot more of the smaller stuff is in the rivers and nearshore area. It just doesn't make it out into the open ocean. And this is now nearly 10-year-old paper, but that's still the general consensus on plastics in the ocean. But also, you know, when we ask the question of why is there so much of it, it's because it's valuable, and it's valuable because it's useful. So in the grand scheme, the global economy, plastics are worth about $625 billion. And one of the wedges on this pie that's actually really important is the light blue packaging that you'll see there, because packaging is almost all single-use plastic. And so that plastic is designed for one thing, and then it becomes waste. Some of these other wedges have uses that make them more easily reused or repurposed. But the single-use plastics are really kind of a terrible problem. In the United States, plastic is worth about $90 billion every year in terms of overall economic impact. And you can see that the most useful ones here, the big bars at the bottom, are polyethylene, polyurethane, polypropylene, and polyvinyl chloride, polystyrene. These are all the really common ones. Polyethylene terephthalate is the plastic that is used in water bottles, and so that one also is a big contributor to the globe, or to the U.S. economy. And so in the whole conversation about plastics and what to do about them, I feel like a really useful construct is the 17 Sustainable Development Goals that the United Nations has put forth. And thinking about how plastic wends its way through the 17 SDGs, and then also the planetary boundaries that are that were put forth by Rockstrom and Company at the Stockholm Resilience Center initially back in 2009. And the 17 Sustainable Development Goals and the 9 planetary boundaries are important constructs, because the SDGs present ways to address the challenges associated with the planetary boundaries. There aren't one-to-one relationships, and there's many-to-one and one-to-many kinds of interactions. But if you're not familiar with the planetary boundaries construct, it's a very sobering perspective on our consumption and the unsustainable nature of that, and the outcomes, the serious outcomes in terms of things like biosphere integrity, climate change, novel entities, stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification, biogeochemical flows, freshwater use, and land system change. And what you can see is that in 2009, they had assessed 7 of these boundaries. They had defined them and assessed them, and determined at that time that 3 of them had already been exceeded. By 2015, they had done more work and determined that a 4th had been crossed in terms of land system change. And now they've assessed all 9 and determined that 6 of them have already been exceeded. And so when you look at the inner circle that has the Earth inside of it, the green is the amount of intensity within each of these wedges of the pie that is sustainable. And so we can take so much and give so much and still be operating in a safe space. But for all of the ones that are red, the intensity of the redness and the extent to which it extends beyond the green circle is how far outside of our sustainability world, really. that we are, and so that then offers some kind of insight into the measures necessary in terms of restoration, not just preservation, but restoration, that are going to be required in order to get us back into a sustainable system. And the 17 SDGs are really important here because those are the recipe books, if you will, for how the experts at the UN see the human systems interacting with these different planetary boundaries. And so we're going to talk a little bit more about that. I put this graphic in here because it really kind of explains what the planetary boundary is, and the things that go into it. This was from the 2009 data set, and so there were 3 planetary boundaries that had been exceeded at this point. The climate change is an obvious one. The rate of biodiversity loss, you know, every time I've ever been to a zoo since I was a little kid, there have been kind of warning plaques on the exhibits that talked about the loss of habitats and the extinction potential for a lot of the different animals in the zoo, right? And so this isn't a new thing either. The thinking about biogeochemical cycles in terms of nitrogen and phosphorus are a new thing, relatively. And those make up the biogeochemical cycles. And I would argue that just nutrients, nitrogen, phosphorus, are kind of an insufficient way to evaluate biogeochemical cycles as a whole. But you see the other categories here of Earth system processes. And if you think about them, it's easy to see how plastic is integrated in each of these different categories, or implicated anyway in each of these different categories. For example, climate change, there's a polyethylene plant under construction in Pennsylvania right now that when it's operational is estimated to produce the same greenhouse gas emissions as 400 coal-fired power plants. It's a single plastics plant. So, you know, in the effort to move from a petroleum-based economy to a more mineral-based economy, as we focus on electricity and battery power and battery storage, and wean ourselves from the petroleum-based economy, it's really critical with respect to plastics to understand that the people who run the oil companies have plastics as their plan B. And the fact that it is so greenhouse gas producing as an industry is really alarming, because they don't have any indication that they're going to just stop drilling for oil and stop converting that oil into new plastics. Anyway, I'll get off of that soapbox for the moment. But if you think about that, then you can see how plastic weaves through each of these other Earth system processes in the planetary boundaries. And we'll talk some more about that. So in that vein, I generated this Sankey diagram that connects the planetary boundaries, which are on the right, and the 17 SDGs that are in the center, as a function of plastics. And ChatGPT sees that plastics affect every one of the SDGs, and then you can see how the SDGs are woven into the planetary boundaries. And I think that this is an instructive way to start to deconstruct the enormity of these challenges into manageable bits. And so I felt like this was a useful tool, and I wanted to present it. And I think we'll see it again. I think maybe I have it in here again later. But I also know that Tammy has expressed a lot of concern about the toxicity of plastics, and I am not a toxicologist or an epidemiologist, but I have some kind of rudimentary understanding of how those disciplines both operate. But what I wanted to point out is that there is an enormous literature, and it is rapidly increasing. So there's a lot of work being done on this front right now. Most of the papers that I have read and compiled in literature reviews are focused on actual particles and the chemistry of plastics. I have not specifically looked at off-gassing and the volatilization of plastics once they're solids. And I'm not sure I understand those mechanisms or the chemistry or the risks associated with them. But I thought I would present a little primer on how we come to toxicity assessments, and you can see why after I go through these next couple slides why they're they haven't really evaluated very many of these things, because it's a process to get through here. So they as I said, I'm not an expert in this area, and it's possible I misunderstand some of it, but I'll give you my Reader's Digest version of it. They have these different kinds of tests, and so acute tests, they want to see, like, what causes an instant reaction at a certain exposure. And then subchronic tests, they want to see if an exposure intensity and duration has caused some kind of illness that they didn't see initially. And then chronic is the same question, but they are trying to figure out more if this creates some disease. And then there are targeted tests where they have very specific kinds of experimental designs where they're trying to figure out a dose response and exposure response. And they do this with computer models. They're artificial intelligence is actually very important on this frontier of exploration, scientific exploration. They also do a bunch of work in the labs, and in vitro literally translates from the Latin to in glass. And so they isolate biological materials, and then they expose them to different chemical types and intensities. And then they have in vivo models, which means in life. So they have model organisms, some of which are also mammalian, but some of the non-mammalian in vivo models that are useful because they have similar kinds of cellular mechanics and processes that are commonly used in vivo models are zebrafish, fruit flies, and some nematodes. This is a lit review that was done on some of these biological models, and they were looking at things like polystyrene. But then they started to do some combinatorial kinds of research. So polystyrene plus BPA. And so what were the doses on these particle sizes at 50 nanometers at 1 to 3 days? And what were the interactions and toxicological effects? So there's a ton of literature, not a ton, but there's a growing body of literature on these kinds of studies. this next one is actually kind of interesting to me because it's not just looking at the toxicity of plastics and plastic chemicals, but it's looking at the interactions of plastics and plastic chemicals with other known toxic chemicals that may be in the environment. So here they looked at low density polyethylene, and then they added in PCBs, BFRs, and PFCs, and methyl mercury. So, and then they looked at different exposures and then quantified the biological response to those. So, but this is an important frontier in the exploration of how plastics behave, again, because they're relatively novel entities. So we don't have a lot of information, and some of these other persistent organic toxins are also novel entities. So our lack of an evolutionary relationship with them means that these things necessarily can't be metabolized by our cellular machinery, and so they end up either accumulating or causing some kind of acute impact. The mussel Asian clam study down here at the bottom also looked at PCBs with a variety of plastics, different doses, different sizes of plastics. And again, like I think that these are actually really important kinds of studies, because we don't really know how a lot of these plastics behave in the environment. But we do know that as they fragment, things stick to them, and they either stick to them chemically, or they stick to them because there is some kind of shape on the surface of the particles that allows these things to grab on there, and then you can get these compounding kinds of potential toxicities. This is more from the EPA's risk assessment on toxicity testing, but basically the model for how they do this is they identify a hazard, and then so some chemical or some suite of chemicals that they're concerned about. Then they do the dose response assessment and the exposure assessment. So they figure out, like, what levels of the chemistry are causing changes, and then how long can you be exposed before you start to see those kinds of changes. Then you run that into a statistical model to do a risk characterization, and then they come up with some kind of plan for how to mitigate it. And then also in this matrix of science comes all of this stuff: the legal, the political, the social, the economic, and the technical challenges. And these are they're relegated to this one box of other considerations, but these are the reasons why such a small number of the chemical formulations in plastics have actually been evaluated for safety. And I would argue that economics and the political are really the big drivers of that. So back to sustainable development goals, and again, I think that these are really important because these are the mechanisms whereby we actually have some kind of system to address the challenges associated with these development goals. And the development goals, as we think about these things and the way that plastic moves through the system, what are the challenges in that risk assessment machinery that the EPA has provided for us? that example of risk assessment machinery. Well, and so what do we do then? This graphic shows how endocrine disrupting chemicals are associated with different kinds of plastics. And endocrine disrupting chemicals really, I want to say 20 years ago, made a big splash because people were freaked out about BPA in baby bottles. And, nobody thinks it's a good idea to have endocrine disrupting chemistry so closely associated with rapidly developing children. And except for the plastics industry convinced us all that that the chemistry in plastic was biologically inert. And really the BPA dust up in baby bottles was our first kind of social awakening, where maybe there's stuff associated with these plastics that are actually not biologically inert and that we should be concerned about. And the values here aren't really important. It's also many of these other chemicals that are here are also not benign, but the endocrine disrupting ones are known, right? They're kind of a known entity of things that we want to stay away from now. As I mentioned before, Neeraj just coming in. I'm going to let her in. The shapes and kind of polarity, the chemical reactivity of some of these molecules allows for other known kinds of toxins to grab onto them, to adsorb onto them on the surface of these particles. And some of these things are known to be really also bad for us biologically in certain concentrations: cadmium, lead, chromium, copper. These things are all grabbing onto plastic particles. And, there is no safe concentration for humans for lead. So the fact that these metals are known to be grabbing onto plastic particles is also another potential pathway for exposure and certainly concern. And again, going back to the 17 SDGs, as an exposure pathway, in this study, they looked at people who are harvesting shellfish on the coast of Washington. And these are not exposed to any kind of high levels of plastics. These are just shellfish that were dug up on ocean beaches. And they looked at the sex of the people. They looked at ethnicity. And, if you think about the 17 SDGs, this represents why it's important to understand plastics and the impacts of plastics in terms of equity and social justice, because clearly women, females, and Native people had high exposure rates. And then also there were other groups like white and Caucasian that also had extreme exposure rates to the plastics from, these are microplastics, from a recreational harvest activity. The thing about the natives is that it's not just recreational harvest for them, it's also subsistence harvest. And so there are social justice issues that arise, and in the 17 SDGs, there are mechanisms embedded in there that can offer some guidance on how we address these challenges. This is just kind of informational in a broad sense. I don't really have a lesson to learn from it, except that shellfish are accumulators, just based on the way that they live. They're filter feeders, and so they're grabbing tiny little particles of stuff out of the water column. And you can see that some of the maximum particles, and these are estimated average number of particles per person per year from eating or consuming these different materials: shellfish, fish, salt, which is really surprising to me, honey, sugar, beer. It's good to know that beer is relatively low. Tap water, bottled water, and drinking water. And you know, it just hits home that the ubiquity of plastics is now really every breath you take, every thing you eat, and every drink you take. You're being exposed to plastics. We are being exposed to plastics. So now though, what can we do? And this is not a comprehensive list, but it's just some things I thought about. I have been thinking about the promotion of reductions in use through circular economies and alternative materials. I think is critical for this. If we take away the markets, then what are they? What you know? Then the market forces will come to play in the insane production of plastics. But also, you know, materials, alternative materials choices. I can tell you in our house, we don't store food in plastic. Many of our glass containers have plastic lids, but they don't have a contact with any of the food. And we use stuff like, you know, it's a little bit annoying sometimes that every glass jar we have gets stuffed in a cabinet, and then, you know, the last 6 pieces of broccoli that nobody ate get put in a glass jar, and then you have all this stuff in the refrigerator. But it limits our familial exposure to plastics, at least within our house. It still comes from the grocery store wrapped in plastic, and much of it comes on a bed of polystyrene, which is one of the most terrible plastics. But you know, there are things that we can do that limit our personal exposure. But also there are industries that are popping up that are doing stuff with bio-based materials, and alternatives that come from things like mushrooms. The mushroom mycelial inventions that are going on right now is really kind of an exciting space. I will say that a lot of the bio-based plastics are not better. And they're not better for a whole bunch of reasons. For example, there was a plastic that derives from the bark of some tree in the Amazon. And I just think that is terrible. We're going to mow down every one of these trees in order to make new bio-based plastics because some marketing guru has determined that bio-based is better than petroleum-based. And the chemical reality is that many of these bio-based plastics are not safer. They're not more durable. They're not more anything. And they cause these other kinds of environmental harms on the 9 planetary boundary framework. The other important thing that we can do is to demand that recycling technologies continue to develop and that they become safer and cleaner. And from my work with some technology partners, both in Montreal and down in Sonoma, California, I have discovered, learned a lot about pyrolysis and gasification technologies that are light years ahead of where they were even 10 years ago in terms of the effectiveness, the cleanliness, the technologies that they have developed in order to address some of the real serious problems that existed initially. And I got to say that, you know, the Europeans, the Dutch and the Scandinavians and Germans have done a lot to promote the development of these technologies and the improvements in the technologies that make them better and more viable alternative than unmanaged mountains of plastic everywhere. And then, you know, in the kind of as another nod to circular economy is the responsible end of life management for plastics. You know, an example is take back programs or the cradle to cradle kinds of circular economic approaches where the manufacturer ends up having the responsibility for what happens to the product at the end of its life. We can do this stuff with plastics. Those frameworks exist. And so those are all things we can do. In the United States, we also have some existing legal authorities and EPA programs that address aquatic trash. There are also some complementary legal authorities that address airborne pollution. I'm not as familiar with, as I mentioned earlier, the physical chemistry, the fate of plastics as they off gas, and or how those regulations would be brought to bear on plastics that are used in building materials, for example. I'm sure that there are legal precedents in existence in the United States and some states that would offer some guidance about that. At least I strongly suspect that that's the case. But with respect to plastic pollution in the water, we've got some very specific kinds of laws about how to deal with that. And the EPA offices, this list is an important one for contacts or where to start looking for how you get the Environmental Protection Agency people engaged in problems that you're aware of that they may not be. More specifically, you know, the real challenge with plastics, as we all know, is that once it's mismanaged and enters the environment, then it becomes terribly expensive and difficult to clean up. So we really need to continue to develop, and we need to require the continued development of solutions that address the lack of recycling with plastics. You've all heard it. There's only 8% of plastics that are recycled. That's it's an embarrassing number. Only 8%. We can do better. And honestly, we can do better. The technology exists. So but then there are other things too, like water filtration. You know, nearly all of the clothing that I own that's got any kind of stretchiness to it has plastic in it. And every time it goes through the washing machine, some of that plastic comes off as micro and nanoplastics. Wastewater treatment plants only address microplastics and nanoplastics by accident. They don't have intentional technology to deal with micro and nanoplastics. So, you know, one thing, if there was an enterprising inventor out there that could be done is to actually come up with an appliance that goes on the back of your washing machine, and then push your local city council, county council, wastewater treatment operator to actually require that these things get put on the back of every washing machine. Because right now, I mean, I can tell you in Puget Sound, in Seattle, our sewage goes to wastewater treatment plants that then the treated water goes in a pipe out into the sound and gets discharged, you know. But plastics are not a technology or a product that they center on. A lot of it gets caught up in the grease and foam that exists in a wastewater treatment processing plant. But still, there's no one, we don't know the extensity and intensity of the problem. And also it's not a technology that is being implemented. The other one that is really important, especially with respect to airborne plastic, is what's coming out of the dryer tube sticking out of the side of your house. Because the dryer pumps micro and nanoplastics into the atmosphere. You can see the lint that gets caught in the lint trap, but every time you go outside, there's more of it on the ground, right? The stuff that you don't see is what's been airborne. And I had a colleague in a meeting at the American Geophysical Union a couple years ago who was doing work in the Sierra Nevada. She's at the University of Nevada, Reno. And last year she sampled the snowpack at the top of the Sierra Nevada mountains up by Lake Tahoe. And she sampled that snowpack top to bottom, and she found plastics everywhere. The whole snow column had microplastics in it, nanoplastics. And that stuff is coming out of our dryer tubes. And anything else that creates basic, plastic dust. And then the precipitation came down and collected it out of the air column and deposited it in the snow. And so then that runs off and becomes part of our spring runoff, right? So it's then this waterborne problem, et cetera, et cetera. I think one of the big keys, though, to this is that we start to imagine that plastic is a resource rather than waste. And because I am 100% convinced that when we can show that plastic has a value of something that is greater than zero, then people will start to actually incorporate it into a circular economy. And now, with the chemical recycling technologies, and the creation of commodities for which there are existing economic economies, like clean diesel fuel, for example. There's no phosphorus in plastic, and so when you pyrolyze plastic and create diesel fuel, you don't have the phosphorus problem that petroleum from the ground has. And while I am not saying that we need to extend the duration of our petroleum-based transportation systems, it's not realistic, especially in developing economies, to think that we can just impose electric vehicle requirements on them in the short term. So the creation of clean fuels that solves a problem is a bridge that can change the value of plastic garbage to something that has a value, and can incorporate people who have otherwise been left out of the economies so that they can now collect the plastic and bring it to a processing place whereby it could be converted into something else, including electricity. And then, there are other kinds of things that everybody knows about. We can volunteer and join beach cleanups and sign a petition and talk with friends and, all of these kinds of things. And all of these are things that we can do that don't cost us anything. They don't take any, and that's not that they don't take any effort, but they don't require any kind of miracle. They just require us to be involved. And my last point is that, when we work together, our voices become amplified, and then things change. And as an example, remember the effectiveness of getting BPA out of baby bottles. And so
So
with that
Ray,
all-
we're at the top of the hour, and I want to make sure that people have a chance to answer, ask questions. Feel free to raise your hand if you do, because I know I've got a few as well, but I'll let Dr. Jack Higgins, who's going to start here.
Thanks, Dr. Tim. That's a lot of information. I'm hoping we have a chance to look at your slides on our own time to study them further. In our club, Rotary Club of Los Altos in California, we've been working with the Trex company that makes the Trex decking. They have a program called Next-Trex where they're recycling the low-density polyethylene that's in dry cleaner bags, your bread bags, baggies, all those sorts of things. With the idea that, well, maybe this is one more thing that can actually be recycled, since right now all the local recycling companies only are really recycling number 1 and number 2 plastics as numbered by the chemical companies. So the question we've had is, what about outgassing? What about, if the Trex boards are outgassing, do we need to have warnings on that? And are we really accomplishing much by doing it? And what about outgassing during the production process, I should say the recycling process of remanufacturing the low-density polyethylene into the Trex boards? I can't find any data on that at all. Do you have any hints as to where we can look?
No. I guess the first thing I would say in response to that is that recycling facilities are notoriously dusty. And that dust is micro and nano sized particles of plastics. A lot of it is. And so it's really critical that those recycling facilities have good air handling equipment, and also that the employees have personal protective equipment and policies and processes in place so that they're not just breathing this stuff. And this is critically important in developing economies where the regulatory environment is different. It's why we see so much offshoring of certain kinds of phases of industry in this country, because it costs less to have people in an unregulated environment do a lot of the dirty work, right? And so but we have to demand that from a social justice and equity perspective, and also a larger environmental perspective, that we have in place proper air handling and personal protective policies and equipment that our workers get access to. I don't know about the impact of the polyethylene in terms of off-gassing once it's reincorporated into the Trex decking. My suspicion is that Trex and similar industries have not looked yet at that, mostly because they're outdoor applications, and so it's difficult, one, to measure, like, what's coming off of a single board that's on somebody's deck, And, there are all kinds of other variables, like, is it in the sun or is it in the shade? Is it how often does it rain, et cetera? What are the things that might cause, what's the pH of the rain? What are the things that might cause any kind of chemical reaction that might allow the material to degrade? So, I don't have an answer for that, but I will say this as a cautionary tale. In Puget Sound, we spend about $1.5 billion every decade. Similar in the Columbia, about $1.5 billion every decade to recover salmon. So about $3 billion a decade to recover salmon. And we just now figured out, not we, I wasn't part of the team, but scientists have just figured out that there's a chemical in tires. It took, I want to say, 15 years of really kind of intensive research, expensive intensive research, to find out that 6-ppd quinone was causing coho salmon, as soon as they come back into fresh water to spawn, to basically lose their ability to move oxygen through their gills. And so they were dying in this phenomenon known as pre-spawn mortality. Well, I'm seeing all kinds of applications for recycled tires now incorporated into road beds. And to me, that's just like, well, I guess we don't care about salmon. We just don't care. If we're going to put the rubber in the road, and then the road drains directly into the roadside ditch, and the roadside ditch drains, which is a roadside ditch is basically double the density of a stream drainage network, right? Now you've got a tributary on both sides of the road that then converge into the streams. And so now you got doses of 6-ppd quinone going directly into streams where salmon spawn. So as a cautionary tale, what I want to say is that there are seemingly good ideas, and they may be good ideas for other reasons. Like the waste management of tires is a huge problem, right? And the hydrologic changes caused by roads is a huge problem. So if we create pervious pavement and use these rubber crumbs incorporated in that to facilitate that, isn't that a good thing? Well, it is, until you consider the chemistry and its effects on fish, right? So it's critically important that, I think, that we maintain some flexibility and ability to change directions once we find out that these are bad ideas from certain perspectives. Not just bad, but potentially disastrous, right? We got to be able to undo stuff like that.
I agree, and thank you for bringing up the tire dust, because I know, Niraj just put it in the chat, but you also shared a slide with me earlier that said how much tire dust is a huge contributor to ocean microplastics. And this is something that I think a perfect example of sometimes you do something for the good of something and you turn out that it wasn't well informed, and you need to shift. But one of the things that we've been talking a lot about is trying to work on stormwater pollution, and that's been a pet peeve of mine for like a decade, and how much what we do in the urban setting is flushing out through our watersheds to the ocean. And this is a perfect example of needing to do what the philosophy of capture rain where it falls, so we're not shifting this stuff out into our water systems. So thank you for sharing that. Andrea, you had a question and then you put your hand down. I'm sorry I interrupted you first.
Oh, no, that's okay. Just quickly, just addressing the whole, Trex decking. There's actually a movie out there called Blue Vinyl, which deals with vinyl siding, same thing. And I'm always in this dilemma of, these products made out of used plastic. It's like, on the one hand, we need to do something with all this plastic. But on the second hand, it's toxic, but it's toxic. We already have it, it's toxic. So I'm always in that moral dilemma. And our Rotary district is talking about Trex benches, because we've been doing buddy benches, and you know, I have to support it, even though like I'm conflicted, but we're conflicted. We have all this, like, we have to do something with it. So that's just my 2
Well,
cents.
thinking forward, it's interesting, Dr. Tim had talked about, there hasn't been a lot of research on this stuff for off-gassing, especially in its application to like housing, but I know that River Recycle is doing a lot of, you know, dredging and cleaning out huge amounts of plastic, and they're mixing it together. It's, according to Dr. Versani last month, it's the actual process where it's so off-gassing, so people have to wear their masks to protect themselves. But the outcome is not so much. Now, I was hoping she could join us together and clarify what does she mean by the outcome after it's done. Seems to me if you scratch that board or whatever, if you turn out these large boards like River Recycle is going to do, are they going to off gas when they have internal inside the house uses? It's one thing with Trex is external, but I've often thought, bring those cute chairs and things into my living room or into my family room. I didn't realize it was because there was an actual, you know, off gassing issue. But they have to meet EU standards, so there must be some EU standards for this because they want to put these boards into use in IKEA furniture. So somehow or another, we got to get I guess I need to look into that more because that's just a piece of this puzzle that I'd like to pull together to make the most informed decision. I do think the other things that come up that we need to push getting people to have washing machine filters, because that stuff just goes right out into the water beds. That's something so simple that Rotaries can do across the country. And I was also really appreciated your comment about the chemical formulation, you know, with the fish. We talk about like, you know, the people think the fish are ingesting this stuff and that's what's killing them, and it is, but it's also the chemical components that they're ingesting and that they're attracted to that is also killing the fish and the birds. Is that a correct assumption? I found that fascinating.
Yeah, can you see this slide?
Not yet.
Let me bring this one.
We can
We
see
can
it.
see it.
Oh,
We
you
could
can?
see it.
The rest of us could see it
Let's
about
see.
the population of salmon declining.
Yeah.
Yeah, we can
There
see
it
it.
is.
There was a study done by a professor at the University of Idaho that showed that 84% of the Chinook salmon in the Columbia River were anatomically female and genetically male. Think about that. These fish, you know, this is an untested hypothesis, but salmon are almost exclusively zooplanktivorous as babies. So they're eating plankton, and to a baby fish, a microplastic piece looks like a Daphnia or some other kind of zooplankton, and but it doesn't swim as fast, right? So they selectively capture microplastics as opposed to zooplankton that have nutritional value for them, and we know that many plastics have endocrine disrupting chemicals in them. So if you think about in the Columbia River, 84% of the Chinook salmon, which are critical for they're the only food for our resident orcas here in Washington and the Salish Sea. They only eat, for some reason, they only eat Chinook salmon. But these fish are anatomically female and genetically male. And so what that means is that if an YY fish spawns with an XY fish, then 3/4 of its offspring will also be YY. This is an evolutionary curve towards extinction, right? There will be no female fish in the Chinook at some point. They'll asymptote probably somewhere down near zero, but the population accelerates downward when you do this. And it doesn't matter what other kinds of things you do. If plastics are implicated here, in addition to things like, you know, the amount of estrogen that comes out of wastewater treatment plant effluent, et cetera, that these fish are exposed to. But if plastics are implicated here, then this is a terrifying outcome. And this is back in 2000, so 25 years ago. James Nagler identified this. The potential pathways. So these are fish that, you know, are conceivably eating, but also could be exposed to just environmental levels of chemistry that are causing this. But we know that in the case of the pre-spawn mortality in coho, that those fish are not eating the tire dust. They're just exposed to those chemicals that are in suspension or in solution. And so, yeah, the numbers of pathways are alarming, but the effects are truly alarming. And these are really kind of unstudied ecosystem responses to or biological responses to changes in the ecosystem conditions as a function of plastics being in them. So I'm not trying to alarm anyone, but I think that this is alarming.
Well, it is alarming, and I think the whole issue of endocrine disrupting chemicals, and I know Andrea's done the same training and research into this as I have. It is alarming, and I think it's interesting how you say these are new chemicals in our evolution, so our bodies can't process them. I've often wondered why they call them the forever chemicals, and they don't, because they enter our bodies, they don't exit our bodies, and it's because our bodies can't process them. I just thought that was fascinating. Getting back to tire dust, because I think I had sent you an article about Kenya is now putting tires and tire remains into their roads, and what you thought of that in terms of road use with this with tires put in that, and this chemical that's going to wash out, I would assume, in rains. Would capturing it and putting it into land, such as in roadside swales, my understanding through research on stormwater collection is that toxins decompose in dirt. Is that something that we should be pushing to educate people to make bioswales so that this stuff is captured in dirt and not being funneled into creeks and watersheds?
Absolutely. Stormwater management is one of the biggest environmental challenges for urban areas in general.
Yeah.
I know that the city of Seattle hasn't met their stormwater permit requirements in a couple of decades. And the pressures for urbanization here are intense and intensifying. The challenge associated with affordable housing, the market people are all about, well, we need more supply. And that means we got to densify our urban areas, but that also means that then we don't have space for things like stormwater swales,
Yeah.
right, and rain gardens, because now the city becomes 100% impervious. And so, you know, we need to really think about all of our 17 SDGs and how we accommodate those things and be smart about it. I would say that one of the things about tire dust is that it's relatively straightforward to get tires. And so tire dust that's in stormwater is a really difficult challenge. But tires in general that are just laying around. I don't know if you've ever driven around southern Baja in Mexico. There's tires everywhere. It's amazing. There's tires everywhere. And when I look at it, I'm like, oh, what a great resource. There's all this stored oil just laying all over the place. And it's you know, there's a lot of really dense carbon there. But one of the things about tires is that it's relatively easy in a gasification environment to make carbon black, which is just pure carbon. That carbon black is necessary for making new tires, but also carbon black is it's the uninoculated form of biochar. So if you can take carbon black and inoculate it with bacteria and fungi and other archaea, you can actually then incorporate that into soil amendments that do things like they're amazing at grabbing water and helping slow the release of water in soil amendments. But also the bacteria and the fungi and other archaea work in conjunction. They use the carbon to provide that along with nutrients to plants. And so we've got all these resources just laying around that can provide us with some really necessary benefits, especially as it becomes more and more important to find ways to feed 8 billion people without knocking down more rainforest in order to do it. Right. So these are the kinds of technological developments that one, promote circular economies, but two, can take advantage of the evolutionary rates of things like bacteria and fungi. You know, in the bacteria that are in our guts, we have a generation time of about 40 minutes. So, you know, if you think about just random mutation and genetic drift, you can get new genomes to develop in the bacteria at that temperature because they're just you get a new generation every 40 minutes. Whereas a generation of humans is about every 20, 25 years, right? So the rate of genetic drift and random mutation is so much faster in organisms like bacteria that are in the soil in a wetland, where they're exposed to these kinds of forcing functions like these novel chemicals, and they have to adjust so that they can exploit these resources. Because the number one, I always say this, the number one most important first principle of ecology is that there are no unexploited resources in nature. And so these bacteria and archaea figure out ways to unlock these things. And you're seeing it with some of the new biological technologies where they're genetically modifying bacteria to exploit certain carbon-carbon bonds in plastics, and degrade plastics. So you know, it's already happening. They have discovered that some bacteria can actually break apart some of the bonds in these polymers And now they're focusing on that as a way to remediate plastic problems. There are challenges with it, and certainly the technology is new. So they're going to get it wrong, but also they're getting it right. They're trying, right? And they're attempting to take advantage of the ability for bacteria and fungi and other archaea to do the things that they do. They've always done it. You know, we have bacteria that live in the most insane environments on the seafloor, and these crazy thermal vents where the things coming out of these thermal vents are toxic to everything that we know about, except that we have these communities of organisms down there that if they came up here would find oxygen to be toxic, and you know, inhospitable environment here. So they're certainly capable of evolving to take advantage of things that we find to be just outright poison.
Well, I suppose, I don't know if anybody else has any more questions, but I'm encouraged that there might be some things down the line, but they feel so far-fetched that we need them like yesterday. And in the meantime, we clean up and we try to look upstream and we try to capture water before it gets to the ocean. And there's just a whole slate of things that we can do to help the situation. I can't help but think that there's going to be a huge petrochemical industry push against anything that's going to really be a great solution set, because their money is made in virgin plastic. How do we shift that economy? As you started your talk with, these are billion-dollar economies. Nobody's going to let go of that easily. So how do we fight against that? And that's not a discussion for today, but it just is something that's, you know, it's like somebody's telling you that there's a cure for the disease, but you keep ingesting it because we haven't turned off the tap, is what the expression we often use.
I
It's
do have
now,
some hope with respect to that. I know we're out of time and I've been talking a lot, but I do want to say that the fact that these are such enormous economies, and also that the enormity of these economies require them to have customers in the EU, means that by 2050 they will all be carbon neutral. That's good news. If they want to do business in the EU, they're going to have to be carbon neutral, and so they will either participate in, or they will directly or indirectly in solutions that help them be able to achieve carbon neutrality. One of the things that we need to be doing, and people like Johan Rockström at the Stockholm Institute are really doing this, and he has a big voice, but we all need to be requiring that we start thinking about our climate emergency as a climate multi-crisis, and addressing all of the 9 planetary boundaries, because the things like what's happening with Chinook salmon in the Columbia aren't addressed by climate change, right? Or you know, the social inequities associated with people who are forced into jobs where, you know, they have these kinds of exposures. Those aren't climate change issues. And so the 17 SDGs and the 9 planetary boundaries as an integrated framework really have to be brought to the front of the economic requirements that companies have to meet as regulatory minima in order to do business in the EU. And if we can, if we are successful in doing that, then these other questions will follow, because it's worth so much money to petrochemical industry. Is it, well, they say 685 billion. This isn't a thing that they're going to just let go. So if we make it so that they have to come up with ways to be neutral across all 9 planetary boundaries, just like with climate and carbon as the surrogate for that, then these solutions will follow based on the model of capitalism.
Cool. Neeraj, did you have, before we well, one more quick question, Neeraj, you had a question? Neeraj is in India.
Microbeads. I was asking about the microbeads. In which products you have the maximum microbeads and which should be avoided actually to have?
Which products are microbeads in?
Yeah, which products have got maximum microbeads and which we should avoid having?
I think the microbeads are in everything, but is in your mind, have you experienced something where it's the most impactful that we might be able to address?
I think that microbeads are generally a solid form of polyethylene terephthalate. So, but I'm not 100% certain about that. But in any case, the polyethylene terephthalate is what water bottles are made of.
Okay.
And that's
microbeads are often seen in cosmetics or body scrubs, and so that was a big issue in the U.S. I think Obama put in a law to eliminate them from production here.
Okay.
There were some loopholes in there, Harold, Dr. Homler, that you pointed out to me, but that's something, again, it's education to people, but definitely they're in a lot of products, and of course, as you pointed out, plastic bottles. So yeah, we probably need to finish up. I just wanted to make comments to those who are still on the phone, and especially to you, Andrea and Connie, because I'd love you to be involved here. Next month, last month, we had a meeting where so many ideas came out that I actually went back through the AI report and wrote like a somewhat of a roadmap of what we can work on in terms of projects. And I think there's so much information out there. People have so much to offer, but the problem is I keep using this example. It's like somebody put 5,000 puzzle pieces at my feet, and I'm like, as plastic solutions person, trying to put them together and not reinvent the wheel. So many people have education. Well, can you get that to this person who's looking for it? And then we can translate in a different language. In other words, there's a roadmap of so many projects that we can make project ready, shovel ready, meaning they're ready to be implemented to any Rotary Club looking for simple projects to do. But we need to get them happening. And next month, I want to focus on just projects, because we have a lot of information now. And as Dr. Tim has shown today, there's still information we don't have. So what can we do to set the best guidelines? For example, helping clean up areas that have so much plastic, maybe with some equipment to do that. But the guidelines have to be that you need to wear eyeglasses, you need to wear masks, you need to, have it be open air. In other words, we need to write down guidelines to say, to the best of our ability, we know that this is as good as it's going to get right now. And how do we also, right now I'm working in Uganda, we were going to do a small type of this project, but now we're going to wrap it into water sanitation, into other things that can overall make a better picture for a refugee camp. In other words, we need to all put our heads together at this point and start this is my classic problem. I think too much and I overthink and I need to just start taking action. And that's sort of what we'll do next month. So give some thought to that, and I'll get out another newsletter on that as well. Dr. Tim Raymond, thank you for your time today. I'm glad we got to the tire dust and the salmon issues, because I think that was also very insightful. And hopefully we will see you again.
Please, thank you again for the invite. But anyone who has questions for me or ideas they want to bounce off someone, I would be happy to interact. I do want to say that there's a company in Montreal that I've been working with who has developed specific technology for waste management and drinking water, to convert waste into safe drinking water.
Okay,
I
well,
can-
I'm going to be all over that, so I will
Yeah.
send you an email the minute
Yeah.
I get off here, so you can send me that information. That
Yeah.
would be awesome.
Yeah, you're welcome.
All right.
Thank
Thank
you
you.
all from coming from all over,
Thank
and
you.
we'll see you next month.
Thank you.
Oh, I
Bye.
think Connie, you and Asha wanted to stay on a few minutes longer and talk. So thank you. Everyone else will. But I know you were going to talk about education stuff. So I'm just going to leave the room open for you.
Thank you. Thanks, Tammy. So that was a lot of information and a little heavy. I'm a little like needing to breathe a little bit. Yeah. So Asha, I know that I don't know exactly what you're doing. And I have talked with Tammy about trying to put together some educational materials. And first we talked about doing it for elementary schools. And I'm sort of thinking, gosh, elementary schools are overwhelmed, and a lot of information, I think, goes towards them now. And then I thought, well, maybe we should focus it on senior centers so that we could teach the seniors about it so that they could teach their grandchildren. And then we get a part of the population that didn't grow up with plastics and aren't aware of how noxious they are sometimes, although they're becoming way more aware of it. But I'm curious where your focus is and what you have done, because it sounds like you've got a very active group going.
Yeah, so just to share in brief, the plastic pollution, trying to find solutions to it. And we tried talking to adults, but it was slightly difficult, to change the mindset. The usual response we would get is, no, we are paying our taxes. It is not our problem. It is the government's problem, so on. So we started off with school students, grade 7th, 8th in India, where they're about 13-year-old or so. So it was a simple sessions that we would take, where we would just create an awareness of the amount of plastics that they are using, the problems the plastic pollution creates, and how they can be a solution to it. So we used to do very simple presentations in a fun way, and playing some games with them, engaging them so that they feel they are a part of it, and they are a part of the decision making, where they can say no to something, where they can say yes to something. That is how this journey began about 7 years ago. We used to, and it was a very bootstrapped program, I was personally funding it. So we started off with a school every year, and then we would continue with the earlier school. And most of the schools that we worked with were from really underprivileged areas. So for them, the area of concern was not plastic pollution or anything else. It was the basic necessities of life, like hunger or clothing and things like that. And we wanted to clean up that area where they were living. And we didn't want to do it ourselves. We wanted them to take responsibility for their neighborhood. So we adopted schools in very low income groups, taught these little children how important it was to use plastics responsibly and change your own neighborhoods. And today I'm so proud to say, we, with the help of donations and fundings, we have got about 73 schools. This year we have got funding for another 25 schools. So we have now totally about 73 schools in our kitty. And what we do is, after the awareness programs, we do conduct some activities with them, and we give them color-coded dustbins and community bins if there is space in the school. So with color-coded dustbins, it is very clear to them that wet waste needs to be put into one of the bins. The blue bin is for dry waste. And we also help them to make eco bricks. And with that, some kind of a big bunny or something like that, so that they know how much of plastics is being generated and what they can do with it. It's not a waste. So we have, I don't know to screen share, otherwise I could have showed you how these children have made benches out of, eco bricks, which is used by them to sit in their own little garden. So in a way, we are trying to teach children that plastic is actually not an enemy. It's a friend. You need to use it responsibly and, use it for a longer time rather than, use it as a single use and, where we reach a position where we need to ban plastics. Rather than that, use plastics responsibly. And we also provide these children with cloth bags, pencil pouches, eco-friendly pencil pouches, simple things where they, bamboo toothbrushes. So it is a sustainable behavior that we want to bring about in them. And today the project is in its 8th year, and we are so happy to see the change in communities, not only in the school, but in the communities where these schools are located. And today we have not only the teachers or the students participating, we have the entire neighboring communities. Most of them are located in slum areas where there might not be proper waste collection and things like that. So it's so in fact, our tagline is transform a nation, adopt one school at a time. So that is in short of what we are doing.
Wow, that's beautiful. Okay. Okay.
Just give a brief introduction about myself. I'm Asha Janardhan from Rotary District 3141. We are located in Mumbai, Maharashtra district. And I'm from Rotary, as I said, Rotary Club of Bombay, Chembur West. A past president and a past district secretary, assistant governor. So I've served in almost all the posts of in district Rotary.
Wow. Okay. Okay. Thank you. Thank you. That is amazing. So you have been involved since the beginning.
Yes, it was actually my brainchild. And how this whole project came to life is I'm from the travel industry. And I would have guests from abroad and I would travel abroad. So the most common feedback that I would get is India is an amazing country. It's so beautiful, it's rich in its culture and all those things. But at the end of it, they would say, but it's dirty. And that is something that I wanted to change. And I started by picking up litter literally at most of the places, especially at tourist destinations. I would stop my car if we are traveling by. I would always have a litter picker and large garbage bag with me. But I realized, one person doing it would not change. So my dream is I'm building a green army of my young little children who will ensure that, they are the eco-conscious citizens of India for the future.
Right. Interesting. You know, I noticed when I was in Nepal that people just throw trash out. Like I spent my time picking it up too. And I thought in the olden days, the trash was not plastic. You know, the trash was biologic. It was like an apple core or something. And so when plastic has then been integrated into the culture, but that habit has not changed, then they were throwing out things that were not biodegradable. So they would start collecting. So I really had a sense of how it has to evolve. Like the people have to understand the importance of it.
Yes.
Yeah, we in the 60s here in the States had a huge push of, prevention of pollution, and it made a big difference. We don't see a lot of plastics on the side of the road or trash on the side of the road because it's just been in us since the 60s for a long time already. So, yeah, so I don't know, like our goals here, our work is going to be a little different from yours, but I so appreciate what you're doing. Thank you for doing that. That's a big project and it's taking off, which is beautiful. So your Rotary clubs have funded you for some of the work that you're doing?
Yes, we have got funding from companies too. In India, we have something called as CSR, which is Corporate Social Responsibility. So now companies are funding us. So this goes towards procuring the dustbins, paying salaries. But whatever I do is totally voluntary as a Rotarian.
Gotcha. Okay. Okay, thank you. Corporate Sustainability Resource, is that what you said, the CSR?
Corporate social responsibility, which
Social
means
responsibility.
companies earning about a certain amount in revenues, they need to, donate 2 to 3% of so towards social causes. So
Gotcha.
we have companies which are donating for these causes.
Gotcha.
Yeah. So we get companies which also donate towards cloth bags. So we will have one small community which is using only cloth bags. They
Gotcha.
wouldn't carry plastic bags. So it is basically also teaching children to adopt sustainable habits. Like
Right.
instead of a plastic toothbrush, we donate bamboo toothbrushes. And so children get used to that. And where possible, they can buy it later in life.
Right. Right.
So we give
Okay.
them to think the end of the life cycle of a product.
Right. Right. Okay. Okay. Thank you so much. So, do you have any questions, Tammy?
I do. Just Asha, do you have anything that you have already written up? Like, are there a coloring book or something that you give to a teacher to tell them what you're going to do? Is there any prototype to that?
We haven't created anything like that so far. We just give them we have one flyers kind of what we plan to implement in their schools. But yes, definitely, if we get funding and support, we would love to have more educational material because currently our resources are towards setting up this program.
And the flyer is something that you give to the teachers, to the principal, who gets the flyer? And in other words, do you go into the schools and go into the classrooms? Or you, what's the process of how you work to establish a relationship with a new school?
Okay, so we approach the principal, we talk to them about, and now it's reached a stage where principals approach us because they have seen the change in the other schools. So earlier, we would approach the principals, talk to them about what we are doing and how we plan to go about it. And we get 1 or 2 coordinators from the school, teachers who will be dedicated to the program. And then we would work on that. And we also provide signages along with the dustbins. That is, how do you segregate your waste? What is wet waste? What is dry waste? And we also provide sanitary pad incinerators. So there are various things in which our motto is zero waste to landfills.
Zero, interesting, you have sanitary pad incinerators. That's, I've never heard of that.
Okay.
Um,
Now, we
I
generally,
have to look that up.
so
Tammy, this is the best place to install in the schools and the hospitals. I
yeah,
installed 6 of them last year in schools and in hospitals.
yeah. So
It's a vending machine for sanitary pads and an incinerator along with that.
yeah. So we promote actually using reusable cloth pads, which India has traditionally been using. Our parents, our moms, our aunts, grandparents, moms have been using it. But today there are various challenges, especially in the slum communities, like there is no water, there's a scarcity of water, or for whatever reasons. So we provide schools also with sanitary pad incinerators so that they can burn the used sanitary pads. It doesn't go to the landfill. So we are working one school at a time where, we first start with the dry waste, which is simple, like, segregate your waste. We give them dustbins, we organize collection drives. The second is the composting part. So once the school is, handling its dry waste properly, then we take care of the wet waste and then the sanitary pad incinerators. So it's a journey with them. So, and we see that overall there's a change in the behavior of students where they want to reduce the usage of non-biodegradable products. They want to live sustainably. So we hope in the long run, when as they grow as adults, they will make wise choices in their lives.
What do you do with the compost? Are you building a compost pile? What do you do with the dry waste?
With
Oh,
the
there's
wet
dry
waste.
waste. Sorry, is it compost waste or is it just dry waste?
See, the dry waste, we give it for recycling, like plastics, paper, metal, and electronic waste. We have tied up with vendors. And the wet waste, now currently we are dealing with the fruit peels and things like that, which schools use it for their plants. We also provide them with plants and pots, soil, so that gardening is an activity that they can take care of.
Oh. Okay. And does your recycling plant, oh, you're doing the eco bricks? What are they doing with the plastic?
Okay, now with the plastics, like say milk bags or any other bags, we give it to the recycler. He takes it away. And, if it's of value, like for the PET bottles and all, he'll pay some amount, which the school uses for the eco club.
Mhm.
Now, most of the things, most of the plastic which comes out from schools are the wrappers or the multi-layered plastics.
Right.
Which is very, very difficult or almost impossible to recycle. So
Right.
we are teaching children to make eco bricks. And as I just mentioned, one of the schools have made a beautiful bench out of it so that parents can come and sit. Now we are making 2 planters around, massive trees so that it can be used as a place where children can eat their tiffin under the tree. So, we are creating small stories along with these and by which children feel engaged and, they get to feel it. They get to enjoy what they are doing.
Yeah.
And now we are making bunnies also out of it. So they feel very proud if their school has a bunny.
Ah,
So it's
perfect.
interesting. It's a multi-pronged approach in terms of, cleaning up the environment, educating them, making something products that they can feel proud of, but at the same time, in the long term, you want them to get away from from these sachet trashes because they aren't recyclable. And I'm sorry then if you don't indulge me, but Neeraj, was having you on the call here on this last little section. Two things that I had wanted for you for next month is for these eco bricks. I saw that you had an actual recipe in one of your things. Can you look through that as a person doing it and think of every little thing that person would ask? For example, if you gave me a soup recipe and it had the ingredients, but it didn't tell me how much, then I would need to know sort of that balance. And then I also really liked your idea of a portable van that drove around to refill people's things so we could get rid of that sachet trash. So I want to learn more about that next month. Okay, there's just so much goodness going on. I think we can pull a lot of these things together if we just have exactly the things need to be written down. So Ashna, I want to always pronounce people's names correct. Asha, can you just write down, and I'm sorry, I don't know if maybe somebody could translate it into English if it's not there, but I would love to have, this is how somebody is working it and how this program is working in Mumbai. And let that be a prototype to someone to work in Kampala, Uganda, and say how they're doing these things. And it's a transitional story.
Awesome. I think,
Happy
sorry,
to do it. And sorry, Neeraj, one
no,
second.
Asha, you're doing such a good job. So what we need to, I mean, I'm a project person, I'm coming from business consulting side. So whatever you have said, I've heard that out. I'll put them in a format sort of thing. I have a format which we can distribute to people anywhere in the world. How to go about doing the things, because that's my specialty to write down the reports. So I've heard what you have said. I'll be in touch with you. So what I'll do is I have a format fixed. So you just fill it up. And we'll convert them into flyers for everybody.
Yeah, sure.
We can
And
distribute to people.
yeah, I would be
Including
happy
the
to
customer.
handhold anybody anywhere in the world to, replicate this model.
Absolutely.
That would be awesome because like I said earlier with my example of the 5,000 puzzle pieces, you are puzzle pieces. And what I want to do is help the people that are connecting to you to say, oh, I can do this. This is actually fairly straightforward. Very, because when I look at stuff, I get overwhelmed unless it tells me A, B, C, D, and it just, or this amount, this amount, this amount. And that's how we come up with prototypes for other people that doesn't intimidate them, that doesn't scare them. And they can take out of this recipe book to say, we have problems, with kids throwing trash, we want to educate our kids and clean up this area. Here's something somebody else did, and it just makes it easier. So that's what I'm trying to do.
Fantastic.
Awesome. Absolutely. Awesome.
All right, well,
So
you both
we will convert Asha's projects action into a report.
Thanks so much. Thanks for staying on today. I appreciate it. And Tammy, I am a little closer to what I want to start doing, but I haven't, but this is not what's needed where I am, right?
Right.
Yeah.
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 I
But
think
I'm
that's the
really,
important thing is that for some people, it's their problems are different. The approach can be a little bit the same, and you take a
Right.
little piece. I look at it as a buffet table. You
right.
know,
And how she
you're gonna
started it and
eat
how it
this
started a
part
little
and
bit
this
at a
part.
time. That's where, you know, when you start, when it's already in process, you're like, how did you do that? It seems impossible. So it was helpful for me to hear how you started it. Thank you so much.
Thank
You're
you,
an
Gauri.
innovator. Yeah.
Thank you for
Okay,
your
I'm
interest.
gonna need to run too. Thank you,
Yeah,
guys.
everyone needs to run, but good
Yeah.
night to
Thank
you all
you.
in
Good night.
India, and
Have a
the
good
day
day, please.
continues
Have a
here.
good day.
Yeah. Thank you.
Alright.
And
Take
then
care.
Tammy, we have you on the schedule for the date that I gave you. I think it's February 24th maybe or so, right?
Oh, okay.
Yeah, for the Rotary. And then we'll have to talk at some point. I will send out an email to you and to the person in charge of it so that you guys can figure out how the Zoom call could go. Okay? Okay, thank you.
Thank
Alright.
you.
All right.
Good night.
Bye,
Thank
guys.
you. Thank you.